But for sure. Hey everyone, I'm Zach Wilson. Today I'm going to be teaching y'all about Kafka and Flink. It should be a pretty interesting lab today. Got a lot of interesting stuff rolling together here. And yeah, I'm really excited to be teaching this class. I know that this Zoomcamp stuff is one of the most impactful ways to give back to the data engineering community. And yeah, it's going to be awesome. I'm really happy to be here.
Yeah, thanks for being here. It's amazing to have you here as one of the instructors. So I took a short look at the content that Zach prepared. It's amazing. So you are all going to love it. And we will put everything in the module information on streaming. So later in a few days, you'll find everything you need there. And I guess that's all I wanted to say. So now, Zach, the floor is yours.
Yeah,
Let's
awesome.
do your
Awesome.
thing.
Cool. Cool. Let me share my screen here. So we're gonna be working today in with Docker Compose, a lot of Docker stuff today, a lot of Flink, a lot of Postgres stuff. So one of the things that I want to just kind of start this off with is we're going to be having four components. There's actually four machines that we're going to be spinning up with Docker to start with in today's lecture and lab. I guess it's more of a lab, but more of a lab today. So if you go to this Docker Compose file, you'll see we'll be using Red Panda. We are going to be using Job Manager, which is going to become from the Flink Job Manager. And then we have Task Manager, which is going to be the Flink Task Manager. And then last but not least is we have Postgres as a nice way to get all of our data in one spot, and we can look at it, we can query it, we can understand what's going on. So anyways, let's go ahead and start that. So I'm going to I'm just gonna do a Docker Compose down real quick to make it so my state is the same as your state. So we can say Docker Compose up here. This is going to create all of these machines. You'll see, if you look at Docker, they'll all be in here now, right? We have our Red Panda, Postgres, Flink, and Flink Job Manager and Flink Task Manager. To make sure that things are actually running right, you want to go to localhost 8081. And you should see an Apache Flink dashboard here that has everything for your task slots. And you should see a 1 here to make sure like the task manager is actually running. And there's probably no running jobs or completed jobs quite yet. That's something we're going to be working on here in a second. We need to get a couple more things set up before we kind of get into Flink. So if we go back to the Docker Compose, we want to get Postgres set up. So you're going to need to use some sort of DB tool. In the homework, I'm recommending dbeaver. In this lab today, I'm going to be using DataGrip. It's going to be the thing I'm going to be using. So when you do this, you're going to need to
I had
add.
a few comments, sorry. For
Yeah,
those
yeah.
who have no idea what data grip is, so in the first module, we used pgadmin for that. So it's a similar tool.
PGAdmin. Yeah, PGAdmin, dbeaver, DataGrips, just a way to run a SQL query on a database, right? And so, yeah, 100%. That's what we're going to be looking at today. So, if you go in and you make a connection, what we can do is you'll set up a connection, and literally what it is the host is going to be localhost port 5432. Username is Postgres. Password is Postgres. Database is Postgres. Just Postgres all the way down. And then you'll have if you're using a JDBC connector, you can kind of use this kind of URL as well, depending on how you're connecting. So this should connect us up into Postgres, and we should have an ability to run a query. So you'll know it's working if you can query the information schema. Great. So this is working really well. So We need to do this because we're trying to set up a landing zone for our data from Kafka, because this is a very common pattern in where you have data that comes from Kafka, it gets read in real time, and then it gets dumped somewhere else, whether that be like a data lake technology like Iceberg, or a transactional database like Postgres, or there's a million different other places where Flink can put data. And so that's what we're going to be going over here in just a second. So what we want to do is we need to go and create our processed events. Oh, one second. This is the wrong one. We need to I have way too many tabs open. Okay. We want to go and create the processed events table, which will be here in the homework, where we want to go and run this query here called processed events, and just run this DDL. And this is going to give us our data table for Flink. So you should end up seeing it in here. It should actually like show up. Right? There it is. Okay, cool. Now we have our processed events table with the two columns that we are looking for. Amazing. So this is going to get us kind of set up for being able to take data from Kafka to Flink to Postgres. That's going to be the other big piece of this puzzle. So now we've worked with both. We saw Postgres and we saw the Flink job manager. So obviously we're going to need to interact with all of these containers to get this to work, because streaming is that's how streaming works, right? Streaming is it has so many different moving pieces to it. But the next thing we're going to want to be looking at is Red Panda. So we want to end up adding data to Red Panda. And like we have a couple different Python files in here that you can work with. We're going to be using this one called just producer.py. And this is going to add just a bunch of test data, just kind of like just some kind of junk data that we're going to be using. Remembering that with Kafka, when you have Kafka has a couple pieces to it when you are kind of loading data into Kafka, right? The big one is it has some sort of server, bootstrap server. So this is going to be like where Kafka, this is like the URL that Kafka is going to accept the event at. And then Kafka also has a topic. And you can think of topics are kind of like, you can kind of think of them as kind of like a table. They're like the table of Kafka, where like you have the ability to accept data and put it into a spot. So this is when a producer connects to Kafka, that's what we're going to be doing here with this Kafka producer. We are going to be connecting to our server on our Kafka server on localhost 9092. This is Kafka. Red Panda simulates Kafka, so we're able to do all of this local. Most of the time, like in like an actual like data engineering environment, this is something that would be spun up in the cloud, probably with a service like something like Confluent, or there's 5 million different ways that you can spin up Kafka in the cloud. But this is going to be the big thing. And another thing here is when you send an event to Kafka, it has to be serialized in some way, because you can send like objects to Kafka, but it needs to be serialized into a format that can be written to disk. And in this case, we're doing just a very basic JSON serializer. The reason why we need to do this is some data types between Python and Kafka and JSON and all the like you have to have an interchange format between systems. So the way that Python represents data and the way that JSON represents data and the way that another language like JavaScript or TypeScript or whatever other language you're trying to work with, they all have different data types and different ways of representing things. And we need to use a standard interchange format in order to push events onto Kafka so that then we can essentially read them from any other language. The most common option to do this is going to be JSON. With that being said, there are other options out there like Thrift and Protobuf, and there's a bunch of other options out there as well that you could definitely look into. JSON is great in the fact that it's very easy to set up. But like it's also not great in that like it is the biggest and it takes up the most space. And this is where if you use something like Thrift or Protobuf, that would be a great thing that you could look into if you want to like take these labs to the next level. So, and that's another way that you can change this value serializer here. So anyways, let's go ahead and actually send some data to Kafka. That's probably something that y'all are interested in. So we have all of this running. I'm just going to open a new window. Okay, so we have a new window here. And then, so in this case, we're just going to say Python 3 src producers producer.py. And then this is just going to dump hundreds and hundreds of data. This is just dumping all sorts of data to Kafka. And you'll notice when I ran that, it is over here. We had a response from Red Panda. That's you can see it here where it's like, hey, like we're actually creating a new segment of data for this test topic, and you can kind of see like the response. You should be able to see this in the logs, assuming that you're not running the Docker in detached mode. So we know that the data got accepted by Red Panda here, and that's going to allow us to kind of move forward with the next step in this process, which is going to be we're going to be going back over to our jobs. So we have a couple jobs here that we're going to be working with. We're going to be mostly working with this startjob.py. The two jobs, the two Flink jobs that we're going to work with today are startjob.py and aggregationjob.py. These are going to be the two files that are going to kind of really kind of show how all of these things work together. So let's see if that actually finished. I think it did. There's the other tab. Okay, cool. Yeah.
Did we send?
We just sent an integer and a timestamp. Nothing fancy here. Like we have there's another one here that we're working with. Like we have two different types of jobs here that we're working with. We're starting with something very, very straightforward and very simple, just to kind of really get people aware of how all of these things work, because we're going to be getting into watermarking and a lot of other things here as well. And we're gonna want to send other stuff here. But we now have our data. We should have 100 or we should have 1,000 events in the data set here that or in the Kafka queue that are waiting to be processed. So how do you do that? How do you actually like connect to Kafka and connect to all of these things? So with Flink, so we're using PyFlink here, and this allows us to actually process all of the data using Python. And with Flink, there are two concepts that you really want to be thinking about. You have a concept called a source, and you have a concept called a sink. A source is things that you read from. A sink is a place that you dump to. And so when we want to read from Kafka, what we're going to be doing is connecting, and then you have to put a couple different parameters when you're creating a table here in PyFlink. You'll notice, let's go over each one of these because I think they're all super important. So this first one, connector. Okay, this can be, there's so many different things that this can be. Like it can be Kafka, it could be like an RSS feed, it could be a REST API, it could be a WebSocket. Like Flink can literally connect to like everything. This is something I think a lot of people have a misconception about with Flink, is that they think it's like very married to Kafka. And its most powerful use cases are definitely like from Kafka, but Flink can be used as a real-time integration tool with other APIs. And a lot of times that Flink can be a synthesizer between like Kafka and a REST API and something else. Like you can join all of this data together as well. Next thing you have is you have your Bootstrap servers. So this is just going to be our red Panda address here. If you have multiple, it's very common that you have like redundant Bootstrap servers when you're working in the cloud. And so like in that case, like you just do a comma separated list where it'd be like red panda 1 colon, it'd be like 9093 or something like that, right? You'd have another URL. Like, and then you just do a comma separated list. That's what Flink expects if it needs to talk with multiple brokers, multiple Kafka brokers at once. That's a very common thing. You need that redundancy in the cloud if you're trying to have like very scalable Kafka systems. Then you have your topic. This is going to be, you can think of this as like, this is the table that we're reading from in Kafka. We defined this over in the other file. I just want to make sure that is obvious, right? So when we did producer.send here, we sent our topic, or we sent to this test topic here. And one of the things that is kind of wild about Kafka is that like there isn't really a schema here. There isn't a schema, right? Because like I could send a completely different event with a completely different schema to the same topic and it would still work. It has a lot less constraints on it than like a table does in SQL. So anyways, that's what the topic does. Now these two are very, very important. So you have in Kafka, or when you're reading from Kafka, Kafka uses these things called offsets. Offsets keep track of like how much of the data you have read. So you can think of it as there's 3 values that you can put here, and we're gonna explore 2 of them. We're gonna explore 2 of them here in just a second. There's 3 values you can put here. You can put earliest offset, you can put latest offset, you can put earliest offset and latest offset. Earliest offset, what that's gonna do is when you kick up Flink, it's just gonna read everything that's in Kafka. Whatever you have, all the way back to the beginning of whatever data you have in Kafka, it's going to read all of it. If you use latest offset, what it will do is it will kick up and there'll be a timestamp of when Flink starts, and it will only process new data that's coming in after the job starts. So that is a big difference. Like if you use earliest, earliest is very often used like when you're like, like backfilling or like restating data. Like you're kind of using Flink. You're using Flink in a way where you're not processing data in real time. You're actually processing data with a delay because you're just processing the data that's been sitting in Kafka for a while. Whereas latest is the more often the time, like how you're going to have Flink be working with like the more real-time data that's coming in as like, people are clicking buttons on your website or whatever event feed you're processing. There is a third option here, and this is where because Kafka, like sometimes what if you want to like read in not everything in Kafka, but not just the most latest, right? So a third option here is you can put in a timestamp of like, I want to read everything from March 2nd, 2025 at 8:05 p.m. because that's when my failures started. So that's going to be your 3 choices here. This dramatically changes the behavior and how much data your job is going to be processing. And then last but definitely not least here is going to be the format. You have to specify what format you are working with. So here you can use JSON, you can use, there's also like CSV. There's a lot of different things that you could potentially read in here, like as your format. So that's another thing to like explore to see how you can make Kafka more efficient. But this is our source. So this is how we're going to set up a source. Interestingly enough, the name of this table doesn't matter that much. Because this is just what Flink is calling this table. Like, so this table only exists, the table name here only exists within Flink when it's running. This table name does not exist anywhere else. So
I have a quick
Yeah, go.
question.
Yeah.
So first of all, just to understand the setup. So Kafka is the how to say is the communication channel where we send. So there is a thing that sends messages to Kafka, right? So the
Yeah.
message is stored in Kafka. In our case, it's Red Panda, but
Yeah.
could be Kafka or something else that implements the Kafka interface. So we send the messages there, and then so this is the communication channel, and then there are things that can read from this communication channel. So for example, it's KSQL,
Mhm.
others, and Flink, right? So Flink can read from there, right?
Yep.
And the way Flink reads, so it looks at this stream of data, and okay, what have I already processed so far, and what is the new, right? And this is the offsets that you mentioned.
Yep.
And I was wondering, so we start Flink for the first time, right? And then there is this stream from
Mhm.
Kafka topic. So it processes the entire thing, everything, all the events that are in this stream, in this topic, right?
Yep.
What if something happens and our job dies, like the process dies, and then we start it again? Does it necessarily process the entire thing again, or how does it work?
That's a great question. So when in terms of that, like, so if you started off with earliest offset, this is just for startup when you kick off the job. So if it dies and restarts, then it's going to be using another thing called, you can enable a thing called checkpointing. So that's a little bit further down here, checkpointing. So what this does is it will read, like, so this will take a snapshot of the state of the job this is set up to have it a snapshot every 10 seconds. So you can have a snapshot of the state of the job at that moment in time. So it knows how far it has read when it fails. So when you restart the job or when you start it up again, it won't read from the earliest offset. It's going to read from whatever the last checkpoint was. And that's a very important thing to enable in your jobs for resilience purposes, is like if something fails, you want to have a checkpoint, or like if you need to redeploy the job, right? Or like you're updating something in the job, you need to definitely have checkpointing enabled so that you can get so that when a failure does happen, you're not starting from the very beginning again, right? Or like the other thing that can be bad is like you're not starting from the beginning, but you are, or because if you use latest, you have a different problem, which is you skip data, like you miss data that like when you redeploy. And these things have some interesting trade-offs, like because sometimes like that is what you need to do because of like how things process and that's where there's like those different architectures, right? Because you have like Lambda and Kappa architecture, where Lambda architecture kind of like just reads Kafka in a batch, where this is reading Kafka as things are coming in. And that's where there's interesting trade-offs there. That is definitely another thing I would definitely encourage everyone listening to this to read up on, is like the differences between those two, because streaming is by its very nature kind of a little bit brittle in that way, where like you have to when things are set up, like, and bouncing back from failure can be a little bit more difficult for sure. But yeah, does that answer your question?
Yeah, it does. Yeah, it does. So when Flink starts for the first time, it creates this table. When
Mhm.
it for some reason fails and starts again, the table already exists. So
Mhm.
then it keeps the checkpoint somewhere in memory or somewhere on the disk, I guess. So
Yeah.
then it realizes, okay, the table exists. This is the checkpoint. From this moment, I need to start.
Yep, and like where the processing needs to happen, right? And like, and it gets complicated, and this is where Flink is really amazing, actually, because a lot of times it might be failing in the middle of a window, right? And then it will have not, it doesn't just keep track of these offsets. It will also kind of serialize to disk like the open windows, because there's going to be, because if you say you're looking at like a 5-minute window and then the job fails 2 minutes deep, then like there's going to be data there that has been processed after the offset, but it's also going to have that data also serialized to disk, right? And that's going to be the other piece of this checkpointing. That's why checkpointing is you want to it has an interesting balancing act, right? It's like you don't want to checkpoint every 1 second or whatever, because that's going to be very expensive. It has like a it has an interesting trade of like resilience versus efficiency that you want to kind of play with, especially at scale. Like with these play examples, it's hard to like illustrate this, but like that is definitely a piece of this for sure. Okay, so when we create this source, right? Let's go down to the actual job here to maybe understand like what's going on. So this is going to be our actual job. You'll see in our our main method here is log processing. It's this log processing function. So with when Flink starts, it sets up an execution environment, right? And then you have this is the environment that like allows Flink to know what's going on and what the state is. And then we are enabling checkpointing, like we just talked about. Then one of the things that's really interesting is Flink actually has a batch mode, right? So when we are setting up our environment settings, you can actually change this. You can actually there's like in batch mode here as well, which allows Flink to kind of just process. It makes it so Flink the job doesn't stick around. It will just process a chunk of data and then it will stop. It'll kind of treat it like more like an airflow or like a more standard batch process. Whereas like in streaming mode, the job will just sit there and keep listening. It'll keep listening for more data and more data. So then we have our table environment. This is where we are actually going to be creating tables and looking at different sources and sinks. And this is where Flink is going to start to understand these kind of things. So this is where we actually create those tables, right? Or create those sources. So you'll see here we have that event source we created. Amazing. So you'll notice here we have a watermark for this source. For this first job, since this first job is just a pass through, all it's doing is it's pulling the data off of Kafka and immediately writing it to Postgres. Watermarking doesn't do anything. Watermarking only matters when you're doing windows. When you're actually like, and a window, you can think of a window in Flink as it's very similar to like running the group by, like a group by statement in SQL. And so, but it's more complicated because one of the things that you got to remember between batch and streaming is some of the data that you're grouping on doesn't exist yet, or some of the data because it is coming in. And so a lot of times, and it's even more complicated than that, because some of the data that you're grouping on might be out of order because the data does not arrive in the right order. And so that's where when you set a watermark, the main thing watermark does is it specifies the tolerance for out of order events. So in this case, we are setting that to 15 seconds. So if you have any events, when you run your group by or your window, if you have any events that are out of order within 15 seconds, it will automatically fix that problem because it's going to wait. So essentially, this adds latency to your processing, but it will wait an extra 15 seconds to make sure that it's captured any incoming events that might be out of order. So that's what watermarking is for, and that's the big thing. And the cool thing about watermarking is you can do it based on a couple different things. You can do it based on data that's, or you can do it based on timestamps in the data, or you can also do it based on timestamps from Kafka, like because there's two events there, right? It can be the event time of when the event happened, or the event time of when Kafka accepted that event, which can be two separate times because of network problems, or like say you click a button on your Android phone and then like you go through a tunnel and that event doesn't get sent until after you leave the tunnel and you reconnect to the internet. That's going to be and so that's where this watermarking is a very powerful way to capture that. But again, this has trade-offs, because from one side you're like, I don't want any out of order events, but then it's like but we're processing in real time. So like you have to, there's a trade, right? A trade of like how much guarantees do you want on your orderedness versus how much latency do you want to add to your job. So anyways, we create our Kafka source. Then we want to create our Postgres sync. So let's just go look at that function real quick. This function is another way that we can create connectors. So in this case, you saw in that last example, we used connector Kafka. This connector is going to be JDBC. And then we have all of our Postgres table is going to be table, just this processed events, which is that same name. This name does need to match the name that we put in our table, right? Just like when we said like, select star from processed events, this table, these need a match, right? So then we have our columns, and this is our just connector example. So this is going to allow Flink to run insert queries into Postgres in real time. So that is our sync. So now this allows us to have tables to then play with, and we can run SQL on. So in this case, what we're going to do is a very simple insert into statement. And then we call dot wait here. So the dot wait here is essentially waiting for new data to come in. That's literally what this is doing. And what you'll see here is we have our source table. This is going to be Kafka, and our sync is going to be our Postgres sync. And then we just have our test data, which is just, it's like an integer. It's an integer 1 to 10. And then we have our event timestamp, which we put in from our producer, which is literally just like an event timestamp. So now y'all are probably like, well, how the hell do we like get this job to run, right? That's probably the next step of this journey. So in the code here, we have let me go back to code. In the code, we have this make file. So you can either use make or Docker compose. I'll use Docker compose for this, but like you can literally use, we have make job, which allows you to actually just it will run this big old Docker compose function. And you'll notice here we're actually calling the job manager, and this job manager is going to be calling Flink to run this this Python file. So Flink is a Java library, right? So in order to get this to run with Python, there's a lot of extra little things that you got to do. That's why you have to add this dash pi here to tell it like, hey Flink, this is not Java, this is Python. So you got to run it like Python. And then we're adding our source files. That's what this is. This py files here is going to be adding the actual source files. And the reason why it's this folder is because in our Docker compose, we copy our source folder here into that. So let's go ahead and grab this guy. Then in here, we can go ahead and run our Docker compose function here. And this should kick it up. Okay, there we go. So you see how that like, it's like, whoa, 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 whoa. It's like our job manager was able to pick it up, right? And let's go back here. So see, now we have job has been submitted with job ID, blah, 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 right? So if we go back, now we'll see we should have a job here. Yeah, cool. There we go. So you see this job is running, and it's gonna so one of the things that's interesting is this is just like a pass-through job where it's just taking data and then dumping it, right? So a lot of the metrics that you're gonna see here are actually all gonna just stay as zeros, because Flink is never actually holding on to any of the data because it's just running right through. It doesn't actually ever like aggregate or hold on to any data. That's why like when you have a simple job like this, you'll notice like a lot of these like bytes sent, bytes received are always going to stay as zeros, even though the job is running. And how do we know that the job is running? Because if we go to Postgres and we query it, we have data. Right, we have data. See, there's all sorts of data here, right? We have we were like this actually Flink actually dumped the data in here that we would expect. And we can see there should be, like, roughly speaking, 1,000 rows of data, right? Oh, 990 rows of data. Maybe did the producer not act everything? That's very interesting. Oh, it's because we started 10. Okay, it does have all the data. It actually has all the data. So one of the things I want to show here, though, is like this job is listening in real time. So, and the way that we can actually see that is, one second, let me go to that file. Okay, so in here we can see what we got. Oh yeah, SRC producer. I'm just gonna dump another 1,000 events into Kafka, and we're gonna see that, like, over here, you see every time I run this query, this count query, you see how it's just going up and up and up in real time. Like, we are just immediately dumping the data into from Kafka into Postgres, and Flink is just listening, just waiting, listening. So this is like definitely pulling in all of the data in real time, exactly as like you would imagine. And this is literally how companies process data in real time for the most part, is they have this Kafka, this Flink, and then like it's a little less common for things to actually be dumped to Postgres versus like a data lake. Like, there's an interesting technology called TableFlow it's coming out that is really cool, that allows data to just flow immediately into Iceberg, and that is going to be like the future of stuff. So now we'll see. We should have almost 2,000 events. Yep, there we go. That worked great. So now what happens here? Like, if we, I want to show what happens, like, if we are, like, what happens, like some stumbling blocks that can happen here, right? So if we go ahead and we just like, I'm just gonna kill the job. All right, I just killed the Flink job, and this is gonna be a beautiful stumbling block that y'all like I want y'all to be very aware of when you're working with this stuff. So then I'm just gonna start it up again, right? So let's see, the checkpointing here should give us what we're looking for. And if the checkpointing's working, then we shouldn't have any duplicates, right? But we do have our duplicates here, right? And the reason for that, right, is because this job got completely removed from the job manager, right? It got completely, because like when I killed it here, it got completely removed. So this is where the checkpointing is you got to be very careful, right, about like how things are working there, right? So if we go back into here, you'll notice with our running jobs, right, we had that job that ran for 4 minutes, but now this is a separate job that is a part of it, right? So the checkpointing is only in for a specific job that you're running from a specific entry point. So that's a very important caveat. And you'll see I just created a bunch of duplicates, right? It was just immediately added, it just doubled up the data. So you want to be careful with that stuff. Like, this is where when you're setting your offsets, like if you're literally like killing all of your jobs like that, then it's better to be careful when you're redeploying the job. It's better to use a timestamp here for these pieces here instead of earliest, because earliest is just going to pull in everything. But like these checkpoints here, when there's failures and it will bounce back, that's fine. So let's go ahead and kill this other job here. You'll see I actually didn't even kill it. You see how they're both still running. Yeah, go. You had something, Alexi?
Yeah, I was just thinking, so the tables we create, they are per job, right? So each
Per job.
of these jobs has their own tables.
For yeah, like especially for the source, like the sync here is going to be the same though, right? Because of the fact that it's all Postgres, right? Yeah. So
when we define the Flink tables, right? So when we say how we want to process them, each job has its own, right? And each job has its own checkpoint, correct?
Yeah. its own checkpoint.
So
Exactly. And
right now
so,
what is happening is there are two consumers that is pulling from the same stream, and now if you execute this job again, we will
yeah.
have double that amount of data again.
Yeah, and that like because it's not like something that Flink is not super aware of like how many other jobs in this space are running. It doesn't understand that, right? This is one of the areas where it is kind of like a little bit dumb, right? It's a little bit like but in a good way. This is actually also a good thing because having that other layer of overhead would be a very complex platform. But like, yeah, all the checkpointing things are encapsulated into one job. So that's where it's important to be able to like. So if we cancel this job, one of the things that you can do is you'll see here. You should be able to. Can you do it in here? There's usually a way that you can. I think it's. Oh yeah, I think you have to do it from the CLI. But what you can do is you can restart the job with new code. If you say you need to make a change or something like that, that is going to be how you do it, as opposed to kicking off a new job. Because then if you restart the job, you can pull from these checkpoints that it's creating, and that's going to be the better way to kind of like recover from some of these like failures and some of these issues, right? So I'm gonna cancel this one too, just to get us into another space here. So one of the things I want to show is what happens if we change this. Let's just change this guy to, we're gonna change this to latest. So now if we go here and we run the job manager here. Okay, so you'll see when we run latest and the job picks up, we are not adding more data, right? We still have that 3,900 rows, right? And so what I want to do is in the producer, I'm just going to add like literally one row of data. Just going to add, we're going to sneak in one. Okay, so I literally added one row of data. So we should see literally just one more row of data here. So because it's essentially listening on at the end of the queue. It's only looking for the very, very last, like the most recent data, only data that shows up after we start the job. So that's going to be the other way that you can do things. Like this is where it comes back to like how you recover from failures here also just depends a lot on like how much you value the completeness versus the latency versus all. There's a lot of different trade-offs when it comes to those things, like of like how you want to recover from failures. But like a lot of times that's where latest is really nice. Like if you just can throw away the data that you're missing there. But and then that's so how it works a lot in like in big tech is they use latest here. And if there's a failure, they just like use latest and then they use Lambda. They use the batch mode to process like the gap of missing data for that space so that like you can clean it up that way. But there's like, this is definitely a space where I want to, there's best practices need to be really like nailed to the ground here on like what the right way to do stuff is. So anyway, that is the like kind of the basic job. This is literally like what I just explained over the last 40 minutes is how to run insert into select star with Flink. It's not too crazy. It's there's a lot of pieces, a lot of moving parts to this, but it's pretty straightforward. So but what if you want to do like a group by? What if you want to do more? What if there's because obviously there's definitely more to this than just like if analytics was just select star, like we would all be done. We'd be cooked by ChatGPT by now. But so let's jump into this other job real quick to kind of see what's going on here. So this job is going to require another we're going to need to do another create table in Postgres so that we can look at this data as it's coming in. So let's go ahead and create this table real quick. So we're going to go into here. We're going to say create table, processed events aggregated. And then we have our event hour. In this case, we can say event hour, and this is a timestamp. And then we have our num hits. It's a big int. Cool. There we go. That works great. So that is going to give us our table that we can then actually run with this job. You might notice the source here is quite literally exactly the same, right? It's literally the same. This is literally copy and pasted from the other job. But you'll notice here, like we actually have, there's a little bit more aggregation logic here. See, here's hopefully some of y'all data engineers would know what this is about, like this group by, right? Like group by is here, right? We have select. There's one of the cool things about Flink is that like you can get it to look. Some of y'all might actually look at this and might be thinking like data frames, like PySpark. It looks kind of like that, but also not. There's a lot of other things going on here that I think are important to think about. But let's just go from the top here one more time to kind of talk about what's happening here, right? So another thing that Flink allows you to do is it allows you. Oh, this is a little buggy. I'll fix that code. This should be every 10 seconds, not every 10 milliseconds. Every 10 milliseconds is a little excessive. So this parallelism. So Flink also is very, very parallel, right? Like, and parallelism in Flink is going to be based on the key of the data. So depending on what you end up grouping on, that's going to be the parallelism that you're looking at, right? So for example, here, right, we have our we're creating a tumble window. That's what this is going to be doing, which is going to be essentially just creating little 1-minute windows that we are going to be looking at our events as they're aggregated and they're coming in. And then this would allow us to process, like we can run 3 jobs in parallel here because the number of 1-minute windows here that could be open at the same time is more than 1. It's actually, this is an interesting problem here. So it's like, okay, if we have a 1-minute window, how many 1-minute windows can be open at the same time? Well, this depends on the watermark of this, right? So if we go back up here, we have our watermark here, which is going to be a 15-second interval. So if we have a 1-minute window and we have a 15-second interval, that means that this parallelism of 3 is not really going to do very much, right? We can do 2. We can do 2 because if you think about it from like a timestamp perspective. So say we're on the 50th second of a minute, then our watermark will have a 15-second overlap there, right? So then that 50 or that minute and then the next minute will be open, right? Or we're 10. Let me rephrase that. When we are 10 seconds deep into the next minute, the previous minute has not closed yet because we need to wait 15 seconds for that minute or for that to close. And that is going to allow us to have a parallelism of 2. If we grouped by more things, right, we could do that. And we actually do have more groups here, right? Because we actually have this test data. And if you remember from our producer here, that test data is literally the cardinality here is very high. Like there's like thousands. We pumped in the numbers 10 to 1,000. So the amount of cardinality here that Flink can actually pull from, this will group these 2 things together. So 3 would work here, but if we were just grouping on the window, it would not. But since we're grouping, I forgot about that. Or forgot that we're grouping on both. So because it's just like with Spark, like when you're grouping on things, like it will hash that set and then it will distribute that key to one of your executors. And it's very, very similar to Spark in that way. And that allows for different levels of parallelism when you're doing these group by transformations. And so we will keep this at 3 right now, because that will allow us to kind of show like how Flink will scale up and how Flink can process things in parallel. Because that's the whole reason we do big data, right? Is the whole concept of like distributed compute. And these settings scale up to terabytes and even petabytes of data, and you can do all of this in real time. So anyways, that is essentially what I have for kind of this setup. So let's go ahead and get this.
Quick
Oh, yeah.
question.
Yeah, go
So
ahead.
with your example, when I'm in a car in a tunnel and then I click a button, not that I should be doing this in a car in a tunnel, but like, okay, imagine that there is an event generated in a tunnel, right?
Yeah.
And then the tunnel is like, I don't know, it takes 5 minutes, but our window is 1 minute. So after we leave the tunnel, the event is delayed by 5 minutes. So it means that it will not be included in our analytics right now, or what is going to happen?
You come like this is you present a very, very interesting example, right? So what you're talking about is so there's two types of lateness, right? So the first type of lateness is, I call it like, when someone's like 1 minute late to Zoom, and you're like, okay, they're not even late because they're just there. There's like an acceptable amount of lateness. And that is going to be, you can think of the watermark as that like amount of lateness that you're like, okay, it's fine. Like you arrived on time, right? But if you're talking about something that's like late, but it's late beyond the watermark, there is Flink has that. Like, let me it's like, let's see, allowed lateness Flink. So you can set that as well. There is so allowed lateness is going to be, it has another, so this is another value that you can set in Flink, which is like what is considered dramatically too late, right? So there's actually two lateness values here. So like in your case, maybe we do set that allowed lateness value to 10 minutes or whatever, right? Then what happens in that case is when you're out of the tunnel and your event gets sent, and these are 1 minute windows, Flink will that data will come in, and Flink will actually go back, and it will like find that old window, and it will create a new window with your data, right? But that also adds another record. It adds another record, and so on your on the other side, on your like on the like sync side, you need a way to like deduplicate the windows to like correct for that. That is something that you need to do. Like if you use allowed lateness, that's definitely one of those trade-offs, like of like how much allowed lateness do you want to do. And that's another thing with allowed lateness. Flink has to hold on to all of those windows on disk. So after Flink like does its group by, and then it and say the 1 minute completes, and then 15 seconds happen after that, then that window is now closed, and that window can be passed to the sink. And then if you create data that triggers a window like that is closed, it will generate a new window, and it will pass that to the sink. Only if that timestamp is within the threshold of allowed lateness. And the default for allowed lateness is 0, but there are jobs that do that, and you can also there's also a way that like you can process this data separately. Like you can do you can side output the late data so it goes somewhere else, so you can like kind of manage the lateness in like maybe in a batch process later on, or like there's a lot of different ways that you can handle this, but like I like the side output is a really solid way to go for like really late data, which will create an interval that is it's the more correct interval, like it's the actual correct count of the events, but it just arrived later because you were in a tunnel. That would be I guess that would be my very like caveated answer to that question.
So let me try to summarize what you said and at least
Yeah.
also make sure I understood what you said. So like with default settings, the event would be just discarded
Yep.
because the arrived lateness is 0, right? So the way it works, so events are coming and Flink processes them. And let's say our window is 1 minute. So we accumulate data over 1 minute. We process them. Let's say we do group by minute and count. So we are interested in the number of events in this window. So once we have the number, we know, okay, this is the minute, I don't know, right now it's 17:55. So for this minute, we had 10 events, right? And then we just, at the end of the interval, we just flush it to whatever source, whatever sync we have. Let's say it's a Postgres database, then we just insert a new record, right? So this is for the default behavior. If we allow lateness, right, then we would need to somehow go back and re-update this the final aggregated value, right? Because we will have set a new window, right?
Yep.
Let's see. Okay,
It
and
will,
then like
it will read. So what Flink will do, if you put allowed lateness here, it everything that's within that window of like the whatever allowed lateness is, like say you do like a 10-minute window, all of the windows within that like time frame will be serialized to disk in Flink as well. So it will read whatever the window was like before the watermark closed. It will read that window, and then it will add your event to the window, and then it will do the new count and the new aggregation. But it does send a brand new that's a brand new like event and a brand new window to your syncs. So yeah.
So you need to have some logic to actually how to say combine these two windows, right? Aggregate.
Yeah,
So like in
like
this situation would be just overwrite whatever is there because the latest one is almost the correct state, right? But like sometimes it would be, I don't know, doing a sum or whatever, depending on what exactly we do in our
yeah. A very
aggregation.
common thing that they do in Postgres is there's a thing called on conflict update, right? Where you just pull in the new count, right? Because it's like where instead of like when we created this table here, right? But we could put like a primary key on this guy, and then we could put on conflict update so that we just update the count to what its actual correct value is. That's a very common way to like handle this situation, but it's like the right way to handle this does depend on the use case though. Yeah, you're totally right about that.
Yeah, amazing. Thank you.
Awesome. So let's go ahead and actually run this job. I think that's probably something that y'all are interested in doing. So let me go ahead so in this case, all you got to do is change this start job to aggregation job. And this will go ahead and kick that off. Oh, I input field list. Okay, I think there's something fishy here. So we have our event timestamp. Oh, because I put window timestamp and I think it's event watermark. Yeah, this should be event watermark. I think that's the issue. Query schema, event, test data. Oh, sync schema. Oh, we need to put the test data column in there too, because we are actually grouping on that. So this needs test data integer. Yeah. And then we have we have the column here as well. So we got to drop this guy though. Okay, let me go ahead and do that. This says test data integer. Perfect. Okay, so now that will give us our, it should give us what we want. So now, just one more time here. Flink's pretty good. It like, there we go.
Instead of just running and silently, failing, it tells you what the problem is, right? So it can analyze the query.
Yeah, you can see like here I'm like, oh, I'm missing the that column, right? And it's pretty good. Like the actual like it gives you very similar stuff to like Spark in that way. So now like one of the things I want to show here though is if we go back to 8081, we should see this. There we go. So one of the things that's really cool now is we actually have like you'll see like remember when we first did like that pass through example that I was talking about. Now we are actually holding on to data, right? And you'll see like we actually get like performance metrics here now of like how much data we're receiving and like where it's coming from. And like we have our records and it's all kind of there, right? So this is working pretty well now. But we should be able to see some data here. Like okay, so I think it hasn't that that doesn't make sense. That is that second. We have the log aggregation, and then this is gonna be from path execute insert aggregated table. Okay, that should be there. So we have our aggregated tables here. It has our test data and num hits. Okay, that like it might take a minute. Oh, it's because I think it's latest. Is it actually reading in? Oh, okay, no, it's earliest. Should be that. Wait a minute. That should work then. Like, is that like for some reason not actually? Oh, there's probably a failure in the insert or something. Let's go into that. Can we go to the exceptions? Okay, let's go running jobs, events, exceptions, exception history. Okay, that's not this one. Just it says that it's just records sent, records received. And then does this have watermarks are only if event time is used? There should be but this does have
Maybe
event.
like you said, we just need to wait.
I mean it should only take like 1 minute though, right? And like yeah, because like it would be this okay, there's something here that is a little bit off, I think. It's because like okay, so we have event watermark, event timestamp for event watermark as event watermark. That should be this should be our watermark because that like I think that it's I know that the group here is a little off. I think that's what it is. Like is it this because this is our tumble window on this. It is reading the tumble window for sure. That's super weird that it's like actually because we have our timeline of it. Okay, checkpoints are actually okay. What's actually okay? The one way to test this is like let's like load some data here. Just like see if that causes it to because okay it definitely picked up that next data, and then this should potentially dump out another row. Like, but there's nothing else in here that I'm doing differently, right? That's super weird. Okay, because this should be grouping here. Like on, okay, so we're creating our window and then we are grouping on that window. But there should be like a watermark thing here. One second. Let me actually throw on like 1,000 records again because this thing should turn red. It should turn red whenever we like dump a bunch of data. Like see, that's like okay, so it is picking up the records here. Like maybe it's the thing that we need to wait on. I don't think so. I think it's not actually picking it up. Usually this stuff's a little bit faster. Like it's because we are only doing a 15-second watermark, right? And so one second. I have another example of this. I was like very close. I have the one second. How did I do it here? One second. There's a watermark for water timestamp. Okay, we got the timestamp there, and then this is window timestamp call. Okay, that is it. Okay, what the hell? Okay. Yeah, it's definitely not loading in the data there. That's like it should be picking up the watermark there though. It's but it's not for some reason. Okay, let me go back and see 1 second. That's not the one. Okay. Go back to PyCharm on Zoomcamp. Okay. So aggregation job. Is there something else I'm missing here? Because we have our group by window, group by, and then we have our column execute insert aggregated table. That and then this has our aggregated sync here is that. And then this is just not okay. I want to check one more time here, and then yep, it's not it's not actually loading into it. That's super strange. Okay, because that is right. And then we are on column event watermark, and that is our event watermark up here. So the one thing, oh, is this different though? Is this 3? This 3 might be wrong. What in the start job, it's, oh, it is 3. Okay. That's not it either then. That's because that's like, sometimes it's like this is converting an integer or it's converting like an epoch to a timestamp. That's super strange. That should have worked. But okay. Anyways, let me like kind of explain what's going on. Like it's for some reason it's not picking up on the watermark. That's the why this is essentially not sending data anywhere. That's what's literally going on. Like because there's just no exceptions though. It's very interesting. Okay, let me think here. Like, okay, like these windows, I know that there's a small thing here. There's some very small thing on this watermark that is not like it's not pulling it in or something like that. It's not like grouping on the right thing. I swear I had this working before.
Yeah, maybe you fix it later and then
Yeah, this will be fixed. This will definitely be fixed in the like by the time like we publish all this code. But anyways, I wanted to go one of the other things I wanted to go over here with because we have like with the homework we're going to be working more with like taxi data and there's going to be a lot more columns that you're going to be working with. So there's many types of windows that you can work with, right? So this is the most basic type of window, right? Is you have a tumble window, which is very simple. It's very like, okay, we're going to cut up our job into 1 minute segments, and that's just how it is. Then you have a sliding window, which is a little bit different because when you think of like a 1 minute window, a lot of people think of like the first minute of the hour. But there's actually another 1 minute window because you could think of like 30 seconds of 1 minute to 30 seconds of another minute. Like that's also 1 minute, but it's a different 1 minute. And it's like half of 1 minute and half of another 1 minute. And so you have so you can have like a sliding window, right? That's like we have that in the so sliding window Flink. This is does it have that? So oh, I think that's what I'm missing. I think it's yeah, I think I'm missing this key by. I honestly think that that's what it is. From because then you have key by dot window. So in this case, that's literally what's missing here. So it's key by and then call and then this is test data. I'm pretty sure that should because now this is a keyed stream. I want to see if that works actually. See if that like actually fixed our problem. But anyways, back to like sliding windows versus okay, tumbling windows. Well, we'll let that run. But like so tumbling windows are very straightforward. They just cut it up into like very obvious things. This, if you live in a batch world, a tumbling window is very similar to like the batch world. Then you have a sliding window, which is where, like I was talking about before, like that, like you can have 1 minute, but you can take the slice of 1 minute from different points. And like, so a lot of these windows kind of overlap. So that can be another way to do things, right? Is you have your overlapping windows. And then this is my favorite. This, like, for Flink, this is, and this will be part of the homework here, is you actually have a session window. So a session window is great because the size of the session is determined by how many continuous events happen within a period of time. So like if there hasn't been any events after a certain amount of time, then that window is closed. And this is a very powerful thing when analyzing like user behavior, because you can think of like when I log into an app and I, click a bunch of buttons and then I leave, but maybe I only leave for 2 minutes and then I come back. That's still technically like the same session. But that's where like when you determine this session gap, and you'll notice like we have like there's going to be this like with gap here that you want to put in. There's a way to do things like where you have a static gap, and apparently they have a dynamic gap now. I wonder what that's about. That's it's something that you can actually define yourself, and on like how to determine if what the gap should be. That's interesting. Most of the time, like at least when I've worked with Flink, the actual way that I've done things is with this static gap. This is going to be the way to think about it. So it's like the window doesn't close at like a specified time. The window closes after a specified amount of inactivity. So after there's been 10 minutes of no inactivity, or 10 minutes of inactivity where there's been no new events, that is where you get that's where it actually get the data, right? That's actually where I'm gonna try to say here. That's where then the window will close and it will pass it to the sink. It will pass it to Postgres. It will pass it to Kafka or whatever. And so this, like, when I've like worked with Flink, these three different types of windows have different purposes. So like this first type of window is just like essentially how to speed up batch. So if you use your tumbling window, this is a great way to speed up batch. Sliding windows are very good for optimizing. Like, so if you want to figure out like your peak, right, your peak user count or your peak growth or your peak whatever, because you use these overlapping windows to find the moment in time where you have the highest or lowest values. And this is a good for like min-maxing sort of thing. And then sessions is very good for like just grouping user behavior together so that you can analyze things in like a group, and you can analyze a set of events as like a session, just like what it talks about here. Like sessionization is super powerful. And like those are essentially the three types of windows. I want to see real quick if that actually if me missing that key by was the actual oh no, that was. Oh, the current table has no column name key by. Keyed. Is it keyed by? It's like, go back here. Oh, no, it says it's dot key by. That's right. Okay. From path table dot keyed by column test data source table. Okay, so I want to just try this one more time, and if this doesn't work, I'm giving up. Okay, so keyed by does not work because columns available, event watermark, because that's super weird. That like should work. Is it after the window? Is that what it is? Is it like, because, okay, so that goes and then that goes and then that. Interesting. Anyways, I will yep. Okay, so key by is not like Flink is lying to me. Like this, the input here is like totally not like, for some reason this key by thing is not working the way I would expect it to. But I think that's pretty much what I had to show for the this lab and this session. Do we have do we have time for like Q&A or and opening stuff like for that Alexi
You
or?
have
Yeah, for sure. I definitely have time. I know that I covered an unbelievable amount of information in the last
Yeah,
like
thank you.
70 minutes. So yeah, definitely.
So apart from Flink, we have other consumers, right? So and then
Mhm.
maybe let's take a step in what I saw in the live chat is the question. Let me just read it. What exactly does Flink do? Why can't we just use Kafka to read and store? So I assume this question. So I assume the question that we have here that in Kafka, in the Kafka Python client, we have producers and consumers, right? So here we saw an example of a producer. This is when we put something to Kafka, and consumer is something that it takes things from Kafka and
Mhm.
processes them, right? And this is a very low level thing
Mhm.
when we just use the library from Kafka to process this. So what's the Flink role here? What are the other options?
That's a great question. I mean, I love that question. I actually in my company, I just use the consumer API 100%. That's all. I use Kafka in my company like for grading jobs. I use it for all sorts of random stuff. But like so there's going to be some cases where Flink's going to be better. Like if you're doing windowing, you're doing this group buying and watermarking and a lateness, like you can do that with the consumer API. Go ahead and manage it yourself though. Like good luck. Like it's like if you're trying to figure out how to like create these new windows that where like someone goes through a tunnel and like you miss their data for 5 minutes and then they come back, like, and then serializing that stuff and the checkpointing and the restarting of the job where it can recover, all of that stuff like is where Flink is going to like just it's going to make Kafka the Kafka consumer APIs look very very like annoying to work with. I would say that those are the main things. Sessionization, like so to summarize, it's going to be job recovery, late arriving data, and windowing. Those three things are the three things that Flink have going for it. Like some people would argue that there's one more, which is going to be around like scalability. Is that like parallelism side of things where it's like Flink, it's a lot easier to manage like the memory of Flink and the parallelism of Flink than it is to manage the memory and parallelism of just a generic like Kafka consumer. It's similar to being like it's kind of asking the question like why use Spark when you can just use pandas, right? And which is yeah, you can use pandas 100% or polars, right? You can use polars and pandas, but like those frameworks just are not going to work like at the higher end of scale and in a distributed way and stuff like that.
But also, correct me if I'm wrong, but
Yeah.
with the Flink, with the Kafka client, we need to keep track of the checkpoints ourselves, of the latest process timestamp. So we need to save it somewhere, right? So we need,
Mm-hmm.
I don't know, be it a file or a database, but we have to manage it ourselves. Here, we don't need to do it because Flink keeps the state for us. That's
Yep.
one. And then another thing is in your first example, when all we did is just the record arrives and we put it in a database. Super simple thing. But
Yeah.
we did not need to actually write the insert code. So because we used the implemented code that uses Postgres as a sink,
Yep.
which means that all the code for writing to Postgres is already written. We don't need
Mm-hmm.
to. Uh, sorry, something
Have like a
happened.
separate step or like a separate thing going like or like having to like yeah it has like a lot of those good connectors like the JDBC connectors are really nice, right? And you don't have to like bust out what Scicop PG2 or something like that to like do it, right? Yeah, for sure.
My screen just went black. I don't know. I have no idea what's happening. I think some hardware
Yeah,
stuff. I'm sorry, I cannot see you, Zach, anymore.
I can
Uh,
hear you, so that's something.
Good. Yeah, yeah, that's good. So what I'm going to do right now is I will just continue reading questions from the live chat, hoping that my laptop will recover and I will not have to buy a new one.
Yeah, right. So it
The
doesn't
idea
just
of that.
fall off a cliff, right? Yeah.
So another question is like, what are the use cases of streaming? Because for many things, we don't necessarily need streaming, right? We can process things with a batch mode. Like maybe we can process them, like the events that come in mini batches of, I don't know, 5 minutes. I don't know if 5 minutes is a
Mm-hmm.
mini batch, but like we can process events. We can let them, even if we use Kafka, we can let them accumulate and then have a job that we trigger every 5 minutes, that just everything that is accumulated in Kafka, we just take it, process it, and save somewhere. We don't necessarily need streaming. But there are
Yeah.
cases when we definitely need streaming, when we want to process to event within, I don't know, 1 second after it arrives. So what are these
Yeah.
cases? When do we actually need streaming?
That's a great one. I think that so most data engineers work with analytical data. And the number of use cases for streaming in analytical data is not very high. It's not very high. Like, I just want to talk a little bit about one use case or two kind of use cases that worked in my career. So like one was when I worked at Netflix, we were trying to detect when an employee's laptop got hacked, right? And we wanted to be able to respond to that in real time. So when you're asking the question, should I use streaming or should I use batch? There should always the follow-up question is something going to happen in real time on the other side? Because it's not usually worth it to give people like full streaming data just so that an analyst can look at it and have 100% up-to-date data all the time. That's like usually that's what's called over engineering. But like if there is, for example, when I worked at Netflix, where it's like we detect a threat and then we actually push that, we like quarantine that user's account based on the streaming data. And it's like it's much better to do that immediately than in 5 minutes or 10 minutes that give them a lot less access, a lot more time, a lot less time to do damage, right? And so there are some cases like that. Like other examples would be like Uber's like surge pricing, right? You would want that in real time because that's again like 5 minutes can be a very big difference for supply and demand, right? There's like it's like if there is an automated process that will change something on the other end of your pipeline, streaming is a great choice. If you're if there is no automated process and it's just a human that is looking at data, then like the odds that they need it in real time very low. And micro batch is going to be easier to maintain. It's easier to maintain. Like I've found that like I love two different micro batches. I love hourly batches and every 15 minutes. I love those two. I find every 5 minutes is if you're like working with Spark, I find every 5 minutes to be like a lot because like just like kicking up Spark and kicking off the job takes like 1 minute,
Right.
right? And it's like, and so it like becomes like the overhead of how much like the percent of the job that's dedicated to just startup becomes a lot higher the smaller and smaller the batch becomes. So there is kind of a sweet spot there for sure of like how small the batches should be.
So basically, when we need real-time React real-time, like in your case,
Mhm.
it was fraud detection, and then like search pricing. Probably there are other scenarios, then we definitely
Mhm.
need it.
Yeah.
Otherwise, 50 minutes batches should probably do, right?
Yeah, for sure. And like in my whole career, I was a data engineer for 10 years, right? And there was literally two use cases in 10 years where I actually needed streaming, right? And they were Airbnb's surge pricing and Netflix fraud detection, and that's it. And then everything else was almost everything was daily batch, and then the things that needed to be lower latency were going to be like master data, like upstream master data that needed to be lower latency because like that data depended on other data that depended on other data that depended on other data. So reducing the latency of that very upstream data set allowed for the downstream pipelines to work. That's what I did. I deduped notification events, and I actually tried doing that in streaming, but like an hourly micro batch was a much better fit and a much more resilient choice.
And I guess also when it comes to engineering complexity, maybe for a use case like that, like fraud detection, you need an entire team because it's very complex. But if we talk about batches, maybe just one data engineer is enough to maintain even a couple of batch jobs, right?
Yeah. And one other caveat that I have with streaming that I think is very important to talk about is like the idea of like, what are the skills on your team? Because like streaming is like kind of a niche skill. And if you're on a team of data engineers, like a lot of times, like you might be the only one who knows streaming. And so there's a side of this that like this is where you want to work with your manager before you implement a streaming job, because there's a side of it that's like, well, if you're the only one who knows streaming and you're the only one who knows how to troubleshoot this job, then what will happen is you'll be the only one who's on call. And then you're just
Yeah,
on
right.
call all the time. And that's like, it's one streaming. I've seen this happen again and again with like data engineers who are like, and they're very excited and really happy to learn this because it feels fancy and exciting. But then like, when the rubber hits the road and they're like, wow, like I actually have to now maintain this. And then it's on them to teach their team streaming so that they can have a day off. Right. And that's yeah, I've seen that happen a bunch. That happened to me at Netflix. So I definitely there's a lot of caveats with like this technology. Even though it's very powerful, there are a lot of caveats for sure.
Mm-hmm. So what's your opinion on Spark streaming versus Flink streaming?
That's great. I love that. I love this question. I ultimately think that they are going to converge. Databricks is investing very heavily in Spark streaming, and they have Spark streaming and like Delta Live Table. Those two things together are ultimately going to get there because right now they're not like Spark streaming and Flink are different in a very significant way. In that, like Spark streaming is just extremely small batches. It's just micro batch, right? Where Spark streaming pulses like every 15 seconds or every 30 seconds, right? It does just a very small pulse. Whereas Flink is genuine continuous processing where like the event comes in and it flows through, right? It doesn't like it's like the difference between push architecture and pull architecture, where Spark streaming is still just, it's a very, very tiny pull architecture, whereas Flink is a push architecture.
Right. So because we actually used Spark streaming in the previous modules, so very interesting.
Oh yeah, it's great.
Yeah.
I love it too. So
Yeah. So I see a comment from Michael that in the past, Zach has stated his belief that streaming and batch data engineers should be separate specialities. What do you think about this? Do you still think this is the case? Should we have streaming data engineers as a completely separate role? Because like if we think about the stack and things we need to do, like they are pretty different, right?
yeah, I mean, that is a great question. Like, and at Netflix, they are different titles. They actually are. So like for streaming focused engineers, it's actually their title is software engineer, comma data. Whereas for data engineers who are more batch and business focused, they have the data engineer title. So like I am generally a fan of that. I'm generally a fan of like the idea that these are separate roles, that they are like actually like, because a streaming job is much more like owning a server. It's more like owning a website and a server and a REST API than it is like owning a batch pipeline or an offline process. Like, and so yeah, for sure. That's like I find that like if you are working in this space, that like this is a great way to like really expand your technical skills though. And it's a great way for data engineers to like push themselves to like really like get more technical because it's difficult stuff. It's definitely like it's challenging, difficult work for sure.
Mm-hmm. And last question. So this one is from me.
Yeah.
So I know from my past that when it comes to scaling Kafka, it's difficult because you have these shards. So you have like multiple, let's say, Kafka streams that are under one umbrella. and you select which shard to send your event by just, I don't know, hashing on your ID or whatever. So you have 10 shards, and then you have an event, you hash on the ID, or Kafka is doing that, and then it selects internally to which substream to send the data, right? And then if you want to add an 11th shard, then like it's kind of difficult because you need to reshuffle the data, right?
Yeah.
So how does the situation, how do you handle the situation? Like, do you, when you provision your Kafka, when you create your Kafka topic, you like over provision, you create, I don't know, 100 shards hoping for growth? Or how do you do? Because like sometimes
Ooh,
during night, for
this is,
example,
I
you
love this. I love this question. So
during
this
the
question
day.
has caveats, right?
Yeah.
Okay. So part of it is, yeah, it's a pain. It's a pain to like, to rekey and to like repartition the data, like repartition Kafka. Very complicated, right? But like, so there's a couple ways you can do it with Flink. With Flink, you can actually do this where like, you have to create a new topic, right? And then you essentially push the old data there, and or so you end up creating a new topic that like dumps the data there, and then you have Flink kind of read out and exhaust the old topic so that like all the data is exhausted, and either like by doing one of two things, like you might have a job that does the transition for you, where it does the copy. It does the copy from old topic to new topic, that like to do a repartition that way. Like it's a very simple job. That's actually that's like 10 lines of code to like actually do that. And then that job runs until because the problem is like then you have all these producers, right? So then you have to like push all of your producers, like you have to push the code change to all the producers to be like, hey, send to this new topic. And then that copies all the data and moves it over. It's better to do that than to over provision. But like when I think about it, like you want to think about like you do want to be thinking about growth of like how much data this is going to consume, because doing this process is not fun. It's not fun. But also having a bunch of extra partitions for your Kafka and like spending extra money in the cloud and like having all this extra like dead space in your cluster is also not good. So it's a very interesting balancing act of those two things. But like I would say that like my perspective is like you want to over provision like a little bit, and then build in room for growth. But like even then, like there's a chance that like if you get a lot more growth than you even anticipate, then at that point you have to do this migration pattern so that so that Kafka and Flink can kind of work together, and you can have more workers, right? You can have more workers processing more data.
But as I understood, the number of shards remains static, so we don't do this every day. So, for example, when during the day we have peak hours, we have more volume of data that we need to process, and during the night we have less volume. So we don't do this every, I don't know, 12 hours.
Definitely not. Definitely not. This is the only time. So the only time that you would want to do this is, so Flink actually has another metric that you can look at called back pressure. So back pressure is, so if your jobs start to get really back pressured, that's when you know that you don't have enough parallelism in your job, and that's where and you'll get signals. Like the main thing that will happen is Flink will start to be a lot slower, and like your real-time data will become less and less and less real time. And so this is something where this is like a one-time thing, or like once a month, or at the most frequent would be once a month. It's probably more like a once a quarter or once a year thing that you would do. And this would only be for topics that are experiencing a lot of growth.
And back pressure is when events are put in the stream faster than they're processed, right? So then
Yep.
like there is, okay, so we accumulate some, I don't know, unprocessed events.
Yeah, because if you only have 3 partitions and then there's so much data coming in, and Flink is like, I have too much work, man. I don't know what to do, right? Yeah, for sure. That's exactly what it is.
And so I was leading with this question to another one. Maybe we can briefly discuss it before we wrap it up. So
Yep.
there is for real-time processing, Flink. So for real-time processing, Kafka is one of the communication channels, as we called it, but there are others. So
Yeah.
Kafka is a topic. It means that we send it. So basically, what I want to say is like there are other things like RabbitMQ, right?
Yep.
So that probably could work better for our situations. Do you know where we can learn more about these things? Like how do we choose? So like, should we go with Kafka always, or should we look at alternatives and
Yep.
how to pick the right tool for our event-driven architecture?
I love that. Like, I mean, it's interesting because like Kafka is really designed for scale, right? Kafka is really designed for, and I think it is misused sometimes actually, like for certain architectures, especially like because you can think of it as like Kafka is gonna, it doesn't have the like a lot of the same level of guarantees that something like Rabbit does, because Rabbit has a lot stronger guarantees, but it doesn't scale and distribute like Kafka does. That's like kind of the trade between those two. So like it's similar of like, when do you pick like Postgres versus Cassandra, right? Postgres is amazing because you have one node and it gives you very strong guarantees of like, hey, my data was sent, my data was not sent. Like it's very consistent. It has that acid kind of compliance to it. Whereas Cassandra is like, well, the data is going to be updated when it's updated, and like, and it's kind of, it's that soft state like that. And so similarly with Kafka and something like Rabbit, right? Like Rabbit has a much stronger, like you could use Rabbit in a way that like Kafka is not very used like in like, oh, like if you have an application that's like listening to stuff. Kafka's used a lot more in like offline jobs, but like Rabbit is great, especially like if you have a use case where you want the data to like show up in a UI and like do an event, or like it has like the big connections of all this stuff. And like, and also if you know the other big thing is like you pick Rabbit if you know the volume is never going to be very big, right? Like, and by very big I mean like, like tens or hundreds of gigabytes at least, right? Like the Rabbit can still handle a lot too, right? Because just like with Postgres can handle like terabytes, right? But like, and sometimes we over-engineer things, and that's where and Rabbit also has like this ability to like route stuff. So it's more than just a broker. It also can like push things in different directions. It has like so if you want data to be sent and published to certain places, you don't need Flink. A Rabbit can do that itself too. It's like a signal sender as well. Whereas Kafka just goes in one direction, right? It's just a giant like fire hose that's pointed in one direction. Whereas Rabbit's more of like a traffic like a traffic router that can like, stop this, do this, move this, move this. It's like a lot. It has a lot more complexity to it in that way. So, which is a good thing because you can do a lot more cool stuff with it.
Would you say then maybe RabbitMQ is like for, how to say, usual backend engineers, software engineers, rather than data engineers, and data engineers they are more likely to work with Kafka rather than like this messaging queues.
Yeah, yeah, exactly. I'd say Rabbit is a lot more likely to be for application engineers. Yeah, for sure.
Okay, well that's it. We took a bit more time, but
Yep,
thanks
this is great.
for taking the time to answer the questions and taking time to prepare the materials and share
Yep.
them with us. So what we are going to do right now is we're going to publish this video. We are going to publish all the materials in the module 6
Mhm.
part of our data engineering course. I hope my laptop is back to life because right now it's just blinking. I do not see you, Zach, right now. Um,
Every time I teach Flink, I always have weird stuff like that happen. And you're not even teaching, but it's I'm teaching Flink, so your laptop has the problem.
okay, so I keep my fingers crossed that when I turn it off and on again, it
Mhm.
works like it
Yeah.
usually does. So yeah, I guess that's it. So I'll just need to figure out how exactly I stop the stream.
Yep.
Um, if I just power off, that should stop the stream, I guess. But
Yep.
yeah, I have to figure this out. So thanks, Zach, a lot.
Yeah, for
Pleasure
sure.
working with you. Thanks everyone for joining us today. So keep an eye on the announcements. We will announce the homework soon. And right now you're still working on Module 5 Spark. So have fun.
Yep. Awesome. Thank you so much. This has been amazing.
Have a nice day. Bye, everyone.
See you.
Yeah, so I'm trying to turn off my computer right now.